anytime you multiply or divide by a negative number, you need to flip the inequality. Because this will make it true now. Like, for example, negative 10 is less than or equal to negative 6, right? That's true, so it should work for this. If I plug in negative 10 for x, negative 3 times negative 10, that's positive 30. That's greater than or equal to 18. That works. So x in this case has to be something less than or equal to negative 6. Because I divided by a negative 3, I flip the inequality symbol. Just flip it the other direction. I want to do like 2 more, and then we'll get out iPads here in just a second. Let's say we had one like this. So if we wanted to solve this inequality, which means we need to get x by itself, in this case we have x's on both sides of the inequality symbol though, right? So we're going to have to get those together on the same side. So first we need to get rid of these parentheses. We're going to go ahead and distribute that 5. Okay. 5 times 2x is going to be 10x. 5 times negative 6 or minus 6 is negative 30. Nothing else changed. So we want to put our x's on the same side of the inequality here. Okay. So let's move this 4x over to the other side. Since it's a positive 4x, we can subtract it. Remember, I only subtract it here because these are my like terms. 10x minus 4x is 6x. Nothing else changed. Over on this side, I'm now left with 0 because 4x minus 4x is 0. To move the minus 30 to the other side, I would then add 30. (6x) greater than 30, and divide both sides by 6. My answer would then be x has to be greater than 5. Any x greater than 5 would make this true. I didn't divide by a negative, so the sign doesn't flip. I treat it just like an equal sign. Okay. Any questions with that? Had x's on both sides, had to get them on the same side. All right, one more, and then we'll get those out here. Let's say you had something like this, last one. All right, I want to give you a minute or two to try this one on your own first and see what you run into. Try this one here. Bunch of us got a good jump on it. Look like we're on the right track. So we're going to distribute that 2 to get rid of the parentheses. It looks like most people did that. Distribute the 2. So we're left with 2y plus 4 greater than, should have 6 plus 2y, right? Okay. We need to get our y's on the same side of inequality because we're trying to get those by itself. So we either need to move this one over here or this one over here. Doesn't matter either way. Let's say we'll move this one. It's a positive 2y, so we're going to subtract it from both sides. That means this is going to become 0, so I'm left with 4. This is going to become 0, so I'm left with this 6. And all I'm left with is the inequality 4 greater than 6. My variables have disappeared or gone. I'm left with something. Is this a true statement, 4 greater than 6? Obviously not, right? It's not a true statement. So whenever my variables disappear and I get something that's not true, there is no solution.
What if it is true?
Good question. If there is true, it's going to be like, remember when you had 2 overlapping lines, there are how many solutions? Infinite. If it is true at the end, it's infinite. If it's not true, it's no solution. Now, in the back of the book, if you get one that's no solution, instead of saying no solution, it's going to put this. It's going to put the symbol for no solution, which that symbol is a circle with like a slash through it. If you want to use that symbol, you can, but in the book will use this symbol for no solution. So if you ever see that as an answer, that's what it means. Okay. But you just proved it has no solution here by saying 4 greater than 6. That's not true. So there is no y that you could plug in here and here that would make this true. Okay. All right. Questions with that one? All right. This is what we're going to. So 2 more cases I want to look at here. That top one. Okay. Get x by itself there. We're going to get rid of this multiplication by 2, so we're just going to divide both sides by 2. Now, here's the question. Negative 12 divided by 2 is negative 6. Does the sign flip? Okay. It's kind of a trick question. Remember I said when you multiply or divide by a negative number, the sign flips. So did we divide by a negative number? We divided by a positive number, right? The answer is negative, or at least this right-hand side of the inequality is negative, but we divided by a positive number. So if you divide by a positive number, the sign still stays the same. If you're ever unsure, go ahead and complete it and then just test it out. Test out something less than negative 6. Let's say negative 100. That's easy. So if I plug in negative 100 here, this could become negative 200. Is negative 200 less than negative 12? Yes, so that works. So only if you multiply or divide by a negative number does this inequality sign flip. Even if this is negative, as long as you divide by positive here, the sign stays the same. Okay. Then the last one down here, when you have 2/3 times x, so you need to undo that multiplication. You're going to divide both sides by 2/3, but dividing by a fraction is the same thing as multiplying by its reciprocal, flip. Right? So whenever you have a fraction out here, you can multiply by the reciprocal there, multiply by the reciprocal there. I can put that over 1. So that's 3 divided by 3, 2 divided by 2. That means it's going to leave me with x there. I didn't multiply by negative, I multiplied by positive, so sign stays the same. 6 times 3 is 18. 1 times 2 is 2. So my answer is going to be x is greater than or equal to 9. Okay. So that's 2 other cases you could see. Only if you multiply or divide by a negative number does the sign flip. Otherwise, it's just like an equal sign.